Assalamu alaikum. This is chemistry, and our today's topic is or today's lecture is about this electronegativity. Now, as we have seen that in case of electron gain enthalpy that we discussed in our previous this lecture in our previous lecture. Now we have seen that the electron gain enthalpy, it is the tendency of an atom to take up an outside electron from some other atom. But so in case of electron gain enthalpy, we see that an atom gains an electron from outside. Now, but in case of this electronegativity, this electronegativity, it represents the relative electron attracting tendency, and we can define this electronegativity as like this. It is the relative electron attracting tendency of an atom by which it attracts the shared pair of electrons towards itself in a chemical bond. That is, in case of covalent bond, the shared pair of electrons, it is displaced slightly towards that atom, especially in case of the towards this electronegative atom. So being relative in nature, this electronegativity, it has got this no specific units, and moreover its value is not constant. Well, as far as this electronegativity is concerned, it has got no specific this units, because it is relative in nature. It depends upon the nature of, actually it depends upon the nature of the atom with which a particular atom is joined, or with which a particular atom is linked or bonded. Now we have got different scales of different scales of comparison have been given for this purpose, in order to measure this electronegativity. Like we have got Pauling scale, we have got this Mulliken scale, etc. But as far as this Pauling scale is concerned, it is most commonly used. We have got here, I have shown here the second period of the periodic table, starting from this lithium, beryllium, boron, this is carbon, nitrogen, oxygen, fluorine. Now you can see the value of this electronegativity, it goes on increasing as we go from left to right across a period. And I have told you why it is so, because there is an increase in the nuclear charge of that of the atom as we go from this left to right, and moreover electrons are added in the same shell. Now you can see for lithium it is 1, for beryllium it is 1.5, then boron we have got 2.0, for carbon we have got 2.5, then for nitrogen we have 3.0, then for oxygen we have got 3.5, and fluorine it is 4.0. It is the most electronegative this element of the periodic table. Now I have shown here this group, this fluorine, then comes this chlorine, and the second member of this halogen family, it has got electronegativity value that is 3.0. Similarly, in case of, you can see I have just shown the first group, I have shown only two elements here. This is hydrogen with electronegativity 2.0, then lithium it is 1.0. So down a group it gets decreased. So now the value of electronegativity, it increases along the period as I have shown here, and it decreases down the group. You can see here, and this halogen group I have shown two elements here also, and then you have got the alkaline this alkali metals, and that is two elements, hydrogen and lithium. I have shown it goes, you can see the value goes on decreasing. Now fluorine is the most electronegative atom or negative element in the periodic table, having its value of electronegativity 4.0, whereas cesium, or belonging to the alkali metals, it is the least electronegative element of the periodic table. Now cesium is the least electronegative element. Now the electronegativity, it is inversely proportional to the atomic radius. Now electron, I will once again repeat, this electronegativity, it is inversely proportional to the atomic radius of the atom, of that atom. Since the atomic radius decreases along the period, it goes on decreasing, so the value of electronegativity also shows an increasing trend. You can see it here, and this trend gets reversed in case of a group. So in a group we see that trend gets reversed, that is the value of electronegativity decreases as we move down the group, because the atomic radii of the elements increases down the group. Now elements which are electropositive in nature, they have got low value of electronegativity, whereas the electronegative elements they have got this high value of electronegativity. Now if we make a comparison between this electron gain enthalpy and this negativity, now both we see in case of this both electronegativity and electron gain enthalpy are electron attracting tendencies. In both the cases we see both are electron attracting tendencies, but they differ in certain aspects, like in case of this electron gain enthalpy, we see that it is the tendency of an atom to attract an electron from outside, that is from another atom, whereas in case of this electronegativity, we see that it is the tendency of an atom to attract the shared pair of electrons towards itself in a chemical bond. Then another difference between the two is that this electron gain enthalpy, it is the absolute electron attracting tendency of an atom. That means there is complete gain of electrons, whereas in case of electronegativity we see it is the relative electron attracting tendency of an atom. Similarly, another difference between the two is that in case of electron gain enthalpy, we see it is the property of an isolated atom. An isolated atom picks up an electron from another atom, whereas this electronegativity, it is the property of a bonded atom. An atom is already bonded to another atom, and it shows this relative electron attracting this tendency. Then we have got another the difference between the two, this electronegativity and the electron gain enthalpy. Now electron gain enthalpy, we know, as I have already told you, that its units are kilojoules per mole, and or we can say it is electron volt per atom. Whereas as far as this electronegativity is concerned, it has got no units, there are only scales for comparison. So this is about this electronegativity. So this is for today, and in our next this lecture we will discuss this ionic radii. So this is for today. Thank you very much.